Hello all, I am Mahan and I'll be speaking on protection and security in Windows and Xv6. If we first look at Xv6, Xv6 is basically a re-implementation of 6th edition of Unix. Being a primitive operating system, much of the focus was on building a working model of an operating system, and then you look to add efficiency to it and more features to it. Hence, hardly any emphasis was on protection and security, and Xv6 has no protection or security features. On the other hand, if we look at a much more modern and advanced operating system like Windows, because it has a lot more features, the variety of threads to it is also much larger. Take for example that as Windows can access a network, files received from a network are a major source of viruses and worms. We'll now look at some of the protection security measures that have been taken in Windows. Authentication. Like most modern operating systems, Windows also provides authentication using username and password, and the account can also be linked to one's Microsoft account. File permissions. So each file and folder has permissions associated with it. We can specify what level of access we want to give to any individual, group of users, or others. These permissions include read, write, and execute, among others. So Windows Defender Security is basically Windows' own antivirus. It continually scans for malware, viruses, and security threats. It performs virus scans by searching for signature patterns of common viruses. A user can also himself initiate scans on suspicious files or folders. Windows device encryption or BitLocker is used to protect hard disk data. Encryption works by encoding your data with a super complicated cipher, which can only be decoded by the computer that generated the encryption. Without logging, all of your data just appears as a string of random characters, and hence, if any hacker gets access to your hard disk, he cannot do anything without logging in. We now look at Windows Defender Firewall. A firewall monitors the traffic coming in and out of your network, and it blocks incoming traffic coming from suspicious locations. This keeps malicious files and hackers away from invading your computer through the internet. So that's Windows security at a glance. We looked at most of these features just now. So we saw how important a feature authentication is for Windows. We'll now look to add it to Xv6. We would be adding simple username password based authentication where the user is only allowed to move ahead after he has entered a valid combination of username and password. Here, I would only like the operating system to be accessible to a limited number of verified people. Hence, I would not be giving the option of creating a new account. However, I would also be dealing that case in case you want to implement it in that way. We need to know a few things before implementing authentication in Xv6, and we'll take a look. So firstly, the Xv6 operating system starts with the init process, which is present in file init.c. This process forks a child, and this child then executes the shell executable where most of the logic of the operating system happens, and which is also where the user does all that he does. This is a code snippet from init.c. So now the idea is that basically we want the authentication to happen before the user has started using the operating system. That is, it should happen before the shell user program or the shell executable starts running. And of course, it should be happening after the init process. So the perfect time for it is just before the shell executable is called. So how do we do that? So we will hence at that point take the username and password as input from the user and try to match it with our records. Our username password records can be stored in a separate file. In case we also want to add a new user. So before performing authentication, we can actually ask the user that do you want to create a new account? And in case the user accounts replies positively, then we can take as input the username and password of the new account that he wants to create, and we can add it to our login file. Otherwise, we can proceed as shown and authenticate the user. However, while storing the login file, we must be careful about one thing, that the password must be encrypted. Otherwise, any hacker, if he gets access to our login file, he can easily hack our operating system. Next, we discuss adding file permissions to Xv6. Firstly, in my version of this feature, for each file, I will be giving permissions for read or write to each user. Only the owner of this file can change these permissions. So no one else can change the permissions associated with the particular file apart from its owner. So the first step for that is that we certainly need to store which user is currently logged in right now. Without that, we won't be able to make out whether the current user has the permission to access the file or not. So we shall do so by adding a user ID field to each process. So we do it inside struct proc, which is in proc.h, and we associate each process with the user that is logged in. When a user logs in, we can set the user ID of that process by using a system called setUID. Similarly, if we create a process by a fork system call, then we can again call setUID with the user ID of the parent. The second step is the main motive, that is to manage file permissions. So for that, what we do is with each file we associate a 2D array of size n cross 2, where n is the number of users. So this would actually be stored in struct inode, which is associated with each file. We use this permission matrix to find the permissions of each user for each file, whether it has read or write permissions or not. Matrix ij indicates whether user I has permission for operation j or not, where operation can be read or write. Now, when any file is created, it redirects to the syscreate system call in sysfile.c. Here we can set the default permissions of the file, where only the creator of the file is given read or write permissions. Whenever a user tries to open a file, then he would be directed to sysopen system call in sysfile.c. And here, before opening the file for him, we should first check whether the given user has appropriate permissions for read or write whatever he wants to do. Now the last step is, what if we want to change the permissions? So like Windows, we will add a cacls command to the shell user program. This is the same command that is used in Windows. And this command can only be run by the owner or creator of a file. It will take two arguments. The first is the file name for which we want to change permissions, followed by a sequence of zeros and ones to indicate the permissions given to each user. Now when a user enters this command, then while handling this file in sh.c, we need to first check that the current logged in user that is trying to make this command is actually the owner of the file. If yes, then we make a system call sys_cacls, which makes changes to the permission of that particular file based simply on the input that it receives. That's it from me. Thank you.